The dawn of everything. A universe is born. Imagine a time before time itself. An infinitely dense point smaller than an atom contained all the energy of our universe. We call this point a singularity. Then, 13.8 billion years ago, it happened. The Big Bang. An unimaginable explosion. An eruption of energy from this singularity marked the beginning of everything. Space and time, as we understand them, came into existence. This wasn't an explosion in space, it was the explosion of space itself. The very fabric of our universe began to expand rapidly, stretching outwards in all directions at once. This wasn't like a bomb going off. Imagine a tiny balloon suddenly inflating to an astronomical size. That's the Big Bang. From chaos to cosmos, the first fleeting moments. In the first fractions of a second, the universe was an inferno. Temperatures were unimaginable, billions of times hotter than the core of our sun. The universe was a seething soup of energy and particles constantly colliding and interacting. As the universe expanded, it cooled, just like steam cooling as it spreads. This cooling allowed energy to convert into matter and antimatter, the building blocks of everything. Imagine water freezing into ice. The cooling universe allowed energy to condense into particles. These particles, quarks and leptons, are the most fundamental components of matter. They interacted with each other, forming protons and neutrons, the very heart of atoms. Think of it like Lego blocks. These tiny particles combine to create the larger structures of our universe. Echoes of creation, the cosmic microwave background. Around 380,000 years after the Big Bang, something incredible happened. Light could finally travel freely. Before, the universe was too hot and dense, like a thick fog. This first burst of light, the afterglow of the Big Bang, still surrounds us today. We call it the cosmic microwave background radiation. It's a faint whisper of the early universe, picked up by sensitive telescopes. Imagine a lighthouse beam that's been traveling for billions of years. That's the cosmic microwave background, carrying information about the universe's infancy. This radiation tells us a great deal about the Big Bang. It confirms that our universe began from a hot, dense state and has been expanding and cooling ever since. It provides a snapshot of the universe in its infancy, a baby picture of the cosmos. Section 4, From Dust to Stars. The universe takes shape. Over millions of years, gravity began to sculpt the universe. Tiny variations in the density of matter caused particles to clump together, drawn in by their own gravitational pull. Imagine dust bunnies forming under your bed. Gravity collected matter into cosmic clouds. These clouds of gas and dust became the birthplaces of stars. As they collapsed under their own weight, pressure and temperature at their cores soared, igniting nuclear fusion. These first stars were massive and short-lived, but they enriched the universe with heavier elements. As stars lived and died, they exploded as supernovae, scattering these heavier elements like cosmic gardeners. These elements then became the building blocks of planets, moons, and eventually, life itself. We are all made of star stuff. Section 5, The Ever-Expanding Horizon. Our universe's journey continues. The Big Bang wasn't just an event in the past, it's an ongoing process. Our universe is still expanding, driven by a mysterious force we call dark energy. Imagine baking a loaf of raisin bread, with each raisin moving further apart as the bread rises. We observe this expansion by studying the light from distant galaxies. The further away a galaxy is, the faster it appears to be moving away from us. This tells us that the very fabric of space is stretching, carrying galaxies along with it. The journey of our universe is far from over. New stars are born, galaxies collide, and black holes devour matter. The universe is a dynamic, ever-changing place full of wonder and mystery yet to be unraveled.